It's the middle of summer, and the heat has stopped being weather. It's become a threat. The air is so thick you can feel it pressing against your skin. Every breath feels heavier than the last. You reach for the one thing that saved you every summer of your life. It's not there. No hum of a machine in the next room. No cool air waiting behind a closed door. No escape. Now imagine that's not a broken appliance. Imagine that's just how the world is. No air conditioning has ever existed. Not this year, not ever. And somehow, people didn't just survive that world, they built entire civilizations inside it, in some of the hottest, most punishing places on Earth. So here's the question that should already be bothering you. How? Before we start, please hit the bell icon and subscribe us, because it's helped a lot. Let's start with something most people never think about, because we've never had to. Heat doesn't announce itself the way other dangers do. There's no growl, no flash, no obvious warning sign. It just rises, quietly, patiently. And by the time your body realizes something is wrong, it's often too late to fix it easily. That's what makes heat one of the most dangerous forces in human history. Not the drama of it, the silence of it. Think about it this way. A predator you can see coming. A flood you can watch rise. But heat creeps into your body from the inside, shutting things down one system at a time, without ever giving you a clear moment to say, this is the moment I need to act. And for almost the entire span of human existence, there was no machine standing between people and that danger. No refrigerated air, no thermostat, no emergency escape into a cool room. So picture this. You're standing in Mesopotamia, 4,000 years ago. The sun is directly overhead. The temperature is already past what we'd now call dangerous, and you have nowhere to go and nothing to plug in. What do? Most people assume the answer is simple. You just suffer through it. Maybe find some shade. Wait for the sun to go down. But that answer falls apart almost instantly, because ancient humans didn't just survive in hot climates. They thrived in them. They built cities. They built empires. Entire civilizations rose in some of the harshest heat on the planet long before anyone had the faintest idea how to generate cold air artificially, which means something doesn't add up. If the heat was truly as deadly as we know it can be, and there was no machine to fight it, how did entire societies not just survive, but flourish? The answer starts somewhere you'd never expect. It starts with a wall, not a special wall, not a magical one. Just thick, ordinary mud brick stacked layer upon layer, the way builders had done it for generations. But here's what nobody tells you about a thick wall in a hot climate. It doesn't just block the sun, it delays it. When sunlight hits a thick wall, that heat doesn't rush straight through to the other side. It has to travel slowly, molecule by molecule, through solid material. And depending on how thick that wall is, that journey can take hours. So picture what that actually means for someone living inside. At the hottest point of the day, when the sun outside is at its most brutal, the heat from that morning is still crawling through the wall. It hasn't arrived yet. The inside of the house stays noticeably cooler than the world outside. Not because of any clever trick, but because of simple physical delay. And by the time that heat finally does make it through the wall, the sun outside has already started going down. The world outside is cooling off, and the heat trapped inside the wall radiates out into a house that's already preparing for night. It's not magic, it's timing. Ancient builders had, without fully realizing the science behind it, turned a wall into something closer to a slow-motion shield. But that's only the first piece of the puzzle, because a wall alone doesn't explain everything. Here's the next problem nobody thinks about. Heat doesn't just come from outside, it also rises. If you're standing in a room, the hottest air isn't around your face. It's collecting above your head, near the ceiling, completely useless to you. So, what did ancient builders do? They didn't fight that. They used it. Windows were kept small and placed high on the walls, not to block light, but to let that risen, useless hot air actually escape while keeping the space near the floor where people actually lived cooler and more breathable. And at the very center of many homes across hot climates, from the Middle East to North Africa to southern Spain, you'd find something that looks, on the surface, like a simple architectural choice. A courtyard, open to the sky, but shaded by the walls around it. Sometimes planted with greenery, sometimes centered around water. It looks decorative. It wasn't. That courtyard created its own private pocket of cooler air, shielded from direct sun for most of the day, feeding gentler air into the rooms that surrounded it. So already, without a single machine, ancient builders had solved part of the puzzle. Thick walls to delay the heat, high windows to release it, courtyards to create shaded pockets of relief. But none of that fully explains the next thing. Because in some of the hottest cities on Earth, people didn't just manage the heat. They found a way to move the air itself. Imagine standing in a city like this, thousands of years ago, and looking up. Not at ordinary rooftops, but at strange, tall towers rising above the houses. No windows facing outward for people to look through. No obvious purpose from the ground. These were wind catchers, and their entire job was almost unbelievably simple and unbelievably clever at the same time. Catch any moving air high above the city, funnel it downward through the tower, and push it directly into the living space below. In a place where the air at ground level might be completely still, heavy, stagnant, suffocating, these towers reached up into the sky to find movement that people on the ground could never feel, and dragged it down to where it was needed most. But here's where the story takes a turn nobody expects. Because in some cities, builders didn't stop at moving air. They asked a bigger question. What if you could cool that air before it even reached you? Underground, hidden beneath the streets, engineers had already built long tunnels called qanats, channels designed to carry water from distant mountains into the heart of the city, without it evaporating away under the desert sun. Now combine the two. Route the air from the wind catcher down over that underground water, and the air that finally reaches the room isn't just moving, it's cooler. Think about what that means. Thousands of years before anyone understood the physics behind evaporative cooling, before anyone could explain why passing air over water pulls heat out of it, people had already built a working version of it, out of clay, out of tunnels, out of trial, error, and generations of quiet observation. And if that sounds impressive, it's not even the most surprising part of this story, because here's a question that sounds almost impossible to answer. In the middle of a scorching desert summer with no electricity, no refrigeration, no modern science of any kind, how did some ancient societies manage to have ice? Not imported ice, not ice carried in from somewhere cold. Ice made and kept in the desert. It sounds like a trick. It isn't. In ancient Persia, builders constructed massive dome-shaped structures rising up from the ground, some of them reaching 60 feet high. From the outside, they almost look like strange ancient monuments, but inside, they were something closer to a machine built entirely out of architecture. Here's how it worked. During the cold nights of winter, water was funneled into shallow pools near the base of these structures. Through a combination of cold night air and a process called radiative cooling, where heat escapes upward into a clear night sky faster than it can be replaced, that water would freeze solid, even in a place that spends most of the year unbearably hot. Once frozen, that ice wasn't left out to melt away with the first hint of spring. It was carried underground into a deep insulated chamber built specifically to trap cold and block heat from ever reaching it, sometimes even connected to wind catchers, keeping air moving and temperatures low. And there it would sit, through spring, through the punishing heat of summer, solid. So picture the moment someone opens that chamber in the middle of a desert summer and pulls out ice that has survived months of heat that would kill an unprepared person in hours. It shouldn't be possible. And yet it happened, using nothing but timing, insulation, and an understanding of how heat moves that most people today don't even think about. At this point, you'd be forgiven for thinking the story is basically finished. Big walls, wind catchers, ice houses, problem solved. But there's a part of this story that tends to get skipped, and it's the part that matters most, because none of what we've just described was available to everyone. Wind catchers, courtyard homes, underground ice chambers, these were often the privilege of the wealthy, the powerful, the well-planned corners of a city, for laborers working outside all day, for the poor crowded into simple structures without any of these advantages. For anyone without access to good architecture, the heat was still exactly as dangerous as it sounds. Ancient societies didn't fully defeat the heat. They carved out pockets of relief inside a world that remained for many people, brutally exposed. And that changes the story, doesn't it? This isn't just a tale of clever ancient engineering, it's a story about who got to survive comfortably and who didn't. About how the fight against heat wasn't just physical, it was social, economic, sometimes a matter of simple, unfair luck. Which brings us to the twist in this story that almost nobody sees coming. Because right now in the modern world, air conditioning is straining power grids to their breaking point during every major heat wave. It's driving up energy demand at exactly the moment temperatures are becoming more dangerous, not less. Some cities have come dangerously close to losing power entirely during the hottest days of the year, the exact moment people need cooling the most. And in response to that growing danger, architects and engineers today are turning back to something old. Buildings are being designed again with thick thermal mass walls, with wind catcher-inspired towers pulling in natural airflow, with shaded courtyards built into the heart of modern structures. The machine we assumed had permanently solved this problem might not be the long-term answer at all. The real answer might be something humanity already figured out thousands of years ago, using nothing but clay, water, wind, and an intimate understanding of how heat actually moves through the world. And somewhere along the way, in the comfort of switching on a machine with a single button, most of us simply forgot it. The next time the power goes out on the hottest day of the year and the silence of a dead air conditioner suddenly feels like danger, remember this: humans have been standing in that exact moment of vulnerability for thousands of years, and instead of giving into it, they built walls that outsmarted the sun, towers that pulled cool air from empty sky, and ice that survived the desert itself. We didn't invent the fight against heat. We just forgot how many times our ancestors already won it.